got a very interesting speaker today, Dr. Thompson, who is a senior lecturer in computer science at the University of Anglia Ruskin. But perhaps he's much more well known for his YouTube channel called AI in Games. I think it's probably the biggest YouTube channel for AI for game development. And for a while, I wanted to invite the creator behind the channel to speak at OpenAI. For some reason, my role model just assumed that someone who lives in the West Coast, like LA or something. But turned out he's actually, it took me a while to Google it, and then eventually found out, surprisingly, he's actually nearby to Oxford, Cambridge. So Dr. Thompson's research interests includes procedural content generation for game design and AI-driven game design. So I think he's going to talk about things beyond what we usually hear about from DeepMind, etc. So if you could give a round of applause for Dr. Thompson.
Thank you very much, and thank you for coming along today. Chin's actually done a great job of introducing me, which makes the next couple of slides slightly redundant, but I will do a quick overview. First of all, I apologise in advance, my throat's a little bit tingly today, so I might have the occasional cough or splutter. But yeah, so today's talk is essentially artificial intelligence within the context of video games. And what I wanted to do is to give a kind of a breadth of understanding of what the reality is of how artificial intelligence is typically employed within the video games industry, the tools and technologies that are often used, and also give you an idea of some of the open opportunities that still exist and are being pursued in both academic and corporate research. So, as just explained there, I actually work in academia. I am a senior lecturer, a fractionally appointed senior lecturer at Anglia Ruskin University in Cambridge, where I lecture in video game development. But I'm also currently teaching the Introduction to AI as an adjunct at King's College University in London. I'm the director of my consultancy company, AI in Games Limited, where I work with a variety of companies, big and small, helping them understand how they can apply artificial intelligence technologies to create interesting solutions for their games. This ranges from myself working with very small companies, hands-on as a developer. In fact, I was working not that long ago with a small company in Sheffield that will hopefully be announcing the title that I worked on for them not that long ago. But also I've been working with some larger companies that are much larger, much better recognised. In fact, I'm just finishing a consultancy project at the moment with Intel Gaming, and I'm currently working on an unannounced project with Ubisoft, which I can't talk anything about at the moment, but you'll probably hear something about it in about a month or two. And in amongst all that, I also work as a video game developer. I co-founded my own company, Table Flip Games. We launched our first project, Sure Footing, 2 years ago. We're releasing it to consoles in the spring, once I finish the console ports. And also we're currently working on our next project called Cenotaph. But as was explained, most people actually know me as a YouTuber, which as a career aspiration wasn't really something I had in mind for my 30s. And certainly, as someone with an academic background, isn't something that is, well, it's not refable, let's put it that way. Most people know me as a YouTuber, and I've been doing this now for 6 years as of March. And what I do is I deconstruct the artificial intelligence behind commercial video games, and I tell people how it works. This is done by actually conducting proper research on how the games are built and developed. This is largely from attending conferences and reading up on whatever presentations or research papers are generated. More recently, due to the success of the show, I now actually get to work directly with games companies who are happy to actually talk with me and share a little bit of their expertise. And beyond that, I also look at academic research, because this is often really interesting bodies of work that wouldn't be seen otherwise, were it not I make an effort to give it some exposure. So for example, some of the work that I covered last year included a variety of different research projects across the world, looking at how to build Super Mario levels using machine learning and a variety of different techniques. And more recently, I looked at the generative design of Minecraft competition, which is a competition designed for players to build procedural generation systems that build entire Minecraft villages. And I'll talk a little bit more about that later on in the talk. But what I wanted to start with was to talk about AlphaStar, which if you were to really kind of look up games and AI and what was the big talking point coming out of 2019, it would be AlphaStar. This was Google DeepMind's exploration of trying to build a fully autonomous StarCraft AI player and specifically in this case StarCraft II, where they work with the game developers Blizzard. And the idea was that essentially we've never had an AI player that could compete at any level with respect to human players, despite the fact there is already a significant body of research amounting to over 15 years in this particular area. And one of the reasons that Google were really interested in this was hot off of AlphaZero and AlphaGo, where they'd been working in Go and chess and shogi, is that the scale and complexity of StarCraft makes those pale in comparison. To give you a quick idea, that we're dealing with micro behaviors of individual units and the macro strategies required to coordinate a battle. You're dealing with 3 different races, the Terrans, the Protoss and the Zerg, each of which have quite distinct and unique properties. And this ultimately leads to a state space that is, by my reckoning, well actually judging from some existing publications, it's estimated that it's 2 times 10 to the power of 1,685 unique possible configurations of the map. This in comparison to Go, which is 2 times 10 to the power of 170. So we're seeing this near exponential increase in state space when we're moving from one of these projects to another. And this is something that academic researchers have been really interested in for a while now. In fact, there's already 2 existing academic competitions dedicated to StarCraft. And over 2 distinct releases, AlphaStar has now become one of the highest ranked StarCraft players in Europe. And this has been achieved by going through a 2-phase training process where they interface with the code base of the game directly, and they've actually been working on, DeepMind were working on this, the PySC2 framework, which would allow them to extrapolate useful pieces of information about the current state of the game, and this would be much more amenable for use in deep learning. So they're applying all this information into deep neural networks. But to actually pull this off, it goes through this 2-phase process. And I realize I'm trivializing a very complicated body of work in the space of 5 minutes. That first of all, it achieves a base level of functionality by supervised learning through expert replay. And this is a really important part because an awful lot of the existing work in creating StarCraft players, if you look at a lot of the existing research, a lot of just trying to get the basics of playing StarCraft is a huge task. Figuring out where to deploy your units to require resources, what are the build orders you need in order to amass your army, and you have to have all that in place within a certain time frame of the match without running risk of immediately being demolished by the other player. And so to do this, working with Blizzard, DeepMind had access to hundreds of anonymized human sessions, like online games that were played between human players. And what they do is they use a process of supervised learning where they get the neural net to effectively be able to replicate these strategies within a certain level of confidence. And what this is doing is that what they called AlphaStar Supervised was capable of defeating the in-game Elite AI, which is a handcrafted bot developed by designers with a 95% win rate. And it already achieved an MMR, which is a multiplayer matching rating of 3699, which already makes it in the top 84% of all human players on the European servers. So with this in mind, they say, right, well, we have a base level of gameplay, now we need to improve it. And they went through a process of reinforcement learning through self-play. This was creating a learning mechanism which was referred to as the AlphaStar League. What was happening was numerous iterations or variations of these AlphaStar bots were being trained within this learning environment for several weeks, running on some of Google DeepMind's TPU-3 cores. I think to the tune of around $20 million, if I remember right. So it's not something you're going to be able to do yourself. What's interesting is by going through this self-play process, they were able to not only bolster the average competence of all the bots they were creating, but identify strategies that were exploitable and find weaknesses within them. And there's actually a very complicated process where they had exploiters, which were specific bots that had objective functions tied into them to say, right, well, we've recognized that this is a particular weakness that's emerging within these players. We now want you to actively antagonize those players. And we want to see if we can find a way to get them to address that weakness in their strategy and resolve it. And these exploiters operated on 2 levels. There was individual exploiters that were looking at sub-clusters of the community of players that they were building, but they also had league exploiters that were looking at the entire population of different AlphaStar players it was creating, and then subsequently identifying these are global weaknesses within all these players, and we now need to address that and fix it as best we can. So this reinforcement learning process is actually being done not just, they played through all this and they went and built a certain level of competence, and then the next thing they wanted to do was to see how good they are versus actual humans. So last year, if you were lucky, and you wouldn't know if you did it, a select number of humans in the European StarCraft II servers were actually pitted against different versions of AlphaStar at varying levels of its skill set, from supervised to mid and final, which was based on different phases of the AlphaStar League training process. But the AlphaStar final boss reached an MMR, which is now deemed at Grandmaster level, and each of the respective factions had slightly different MMR scores, and we can see here that clearly Protoss was the winner in that regard. What's interesting about that is it now puts the AlphaStar final in particular for these three classes within the top 0.15% of all human players in Europe that play ranked StarCraft. Interestingly, I was actually chatting with one of the developers, the researchers behind this a while ago, about whether there's a potential for them to actually have these bots play against players in South Korea, because there's a huge skill difference by and large between the South Korean community versus the European community. The answer was, don't know, but it'd be cool. Now, I decided to kind of talk an awful lot about this at the beginning because it's such a huge breakthrough, and from an academic research perspective, this is utterly fascinating, and I'm looking forward, actually, it's the next episode of the YouTube channel. But when you compare this to how artificial intelligence is actually used in the video game industry, it's a lot different. It's very different, and pretty much what I just described is in no way applied at all within the industry for a number of reasons. One, by and large, it's the cost. That was a very expensive body of research that was conducted, but also it relies a huge amount on existing player data in order to create those bots. Bear in mind, AlphaStar being bootstrapped by expert human play, and also, interestingly, that those systems are quite fickle. That what's been built there isn't actually applicable anymore. So that version of AlphaStar, I actually don't know if I have it written here. I think it was version 4.6.2 of StarCraft II they were built and trained upon. The game's been updated a couple of times since. And subsequently, due to the meta of that game, the specific strategies that emerge within online multiplayer gaming, those bots are no longer sufficient and would actually need to be retrained to readdress the current meta of the StarCraft II game. But yeah, there's actually very little machine learning in the video game industry until perhaps arguably in the last 5 years, 10 at a push, and there's actually a reliance more on trusted and more established AI technologies. And one of the big reasons for this is that video games are essentially a performance theatre. It's a performance art piece. We are creating environments within which players are presented interesting puzzles, and we reward them through successful execution of completion of those puzzles. And I actually picked specifically, this is from 1988 Super Mario Bros. 3, a game that actually takes place on a stage. If you'll note that there's actually curtains at the top and there's a stage at the bottom, and all of the dioramas and platforms are hammered into the back wall. The lead designer, Shigeru Miyamoto, actually admitted finally in I think 2016 that the whole game is an act, it is a performance play. If you have played the game, you maybe remember that the background turns to black as you get to the end of the level, and that's because Mario is always exiting stage right. The whole idea is Super Mario Bros. 3 never happened. And that's pretty much how video games are built, and the thing for that is optimal AI that works as a villain or an opponent is really undesirable, because we want AI to be fallible. We want it to have weaknesses, we want it to be exploited. One of the other big reasons for this is that games are largely these very big collaborative projects. When you're looking at some of the biggest projects that are coming out, the biggest titles, these are usually developed by teams of 200, 300, 400 people, and maybe those are the people that just work in the main studio. This has also been outsourced to other companies all around the world. And one of the things that emerges from this is that AI developers seldom have complete control of the gameplay experience. By and large, AI programmers are working on tools and tech that is resilient and accessible to designers, and this allows designers to create particular experiences they want within the game. Subsequently, animators are communicating the decisions of characters to players so that we understand what's happening inside this character within the world. And historically, there was very little research and development between titles. Video games is very much a hit-driven economy, and as a result, it's very rare that any studios were investing a huge amount of tools and technologies to migrate from one project to another. That has actually changed quite a lot, notably in the last 5 years, but historically it was very rare that a company was investing a large amount of time in improving AI tech for the purposes of creating a new experience in their next title. By and large, everyone just wanted to build better baddies, because if we build better baddies, then they're more fun to shoot, they're more fun to kill, and then that creates that rewarding, enriching power dynamic that historically video games are kind of renowned for. And so to very quickly talk through some of the more prominent tech that's been used over the years, finite state machines, which is a very vanilla form of model-based AI, like classical AI, where we actually have a number of states of behavior and then we transition between them based upon events in the world. Largely popularized by Half-Life, developed by Valve and released in 1998, with also a plug to GoldenEye, released in 1997, because that actually had a huge influence on that title. And this is a very straightforward process that most undergraduate students will build one of these finite state machines at some point if they're building maybe games or game AI or even just classic AI. And this is all it is. We have one state in the world that perhaps the character is patrolling through the environment. They then see something, they see the player, they transition to a chase or an attack state. And it's really that straightforward. And this is still used today. It's not even a case of, okay, well, this is largely outmoded, why would anyone still use this? And I deliberately put this fella up here as a reminder. This is the Cyber Demon from the 2016 reboot of Doom, and I know that the toolchain that is used in the id Tech engine, which is used in games such as the Wolfenstein franchise and the more recent Doom games with Doom Eternal coming out in March, still use hierarchical finite state machines, which are essentially state machines comprised of state machines. But it's not a designer-friendly methodology. It's actually much more amenable to programmers, and the scale and complexity of these, as they increase in the number of states, it becomes really undesirable. Hence, Halo 2 actually pushed forward this paradigm of behavior trees, which is pretty much the most popular AI paradigm right now. Within the AAA video gaming space, it is also the default AI tool if you use Unreal Engine. And what they did was they just transitioned away from having a fully connected graph to having a directed acyclic graph, where we're now dealing with a behavior that is executed from the top, and based on conditions in the world, it will use selectors to decide whether to take one path or another. And then subsequently there are leaf nodes at the bottom of the tree that represent specific behaviors within the game it needs to execute, and there might be use of sequences in order to glue specific behaviors one after the other. And Halo was really helped pioneer this. One of the reasons for that is that the enemy characters in Halo, the Covenant, one of the things for them is they have to be able to react to context. So for example, the player as Master Chief can sometimes be wielding certain larger weapons, or you can be inside a vehicle. And that means that entire subsections of this tree are cut off and disabled because they're no longer relevant in that context. One of the other reasons that this was really pushed forward is that they injected this idea of stimulus behavior, that when an event in the world, kind of taking a global event idea from state machines, that if a global event occurs, it re-executes the entire tree from scratch. And this allows for very fast dynamic properties where characters respond to, maybe the player eliminates the lead enemy in a unit, and subsequently all the smaller enemies around them can start panicking as a result. And this is actually a behavior that's embedded within the Halo franchise. Around the same time, strips planning was actually adopted. This is strips planning from the Stanford Research Institute problem solver from 1976, largely used in areas of logistics and even in like Mars rover technology or lunar rover technology at the time. Planning systems are built on the principle that we establish preconditions to actions and then we model the effect of it. And one of the ideas that came out of Monolith was what they call goal-oriented action planning. So it takes a finite state machine and it reduces it to this 3-state model, where each character in the world only does one of 3 things. They go to a location, they animate with an object in the world, maybe an object they have at hand, or they use a smart object, which is maybe some contextual element, like maybe they knock over a table or jump through a window. but the transitions and the grounding of variables of what's happening when they're going into those states is being fed by a planning system. So it actually figures that maybe you're going to run 10 transitions through this graph, but we're saying, maybe we want you to go to this location, I want you to knock over the table, and then I want you to go to cover behind it. You're going to then blind fire against the player, and maybe throw a grenade, which gives you enough of an opportunity to run to another point and cover. And ultimately, this interestingly, fear is still held as one of the highest and best examples of AI in first-person shooters. This game is 15 years old, and people still talk fondly of fear as one of the best AI in video games, which is fantastic for the developers. I think it's also a little depressing in some regards, like looking at the current state of AI in games. But it does a really great job of communicating what those characters are trying to do, particularly when they work together to eliminate the player, which actually they're not working together. One of them decides to do something, and he tells another character to tell him to do it. So if he decides he's going to throw a grenade, he tells the other one, could you just say a line of dialogue to me that says throw a grenade? And then, of course, when you're playing the game, one of them's like, throw a grenade! Roger! And he throws it, and you think, oh my god, they're talking to each other. It's all smoke and mirrors. It's performance theatre. And Director AI has become a very popular mode, particularly in larger AAA games, where you're dealing with these large, expansive open world environments where you need to keep making the game interesting for the player. By and large, these are finite state machines. And what they're doing is they're modeling player information in real time in order to guide particular systems within it. So the Director AI was popularized by Left 4 Dead, which is a 4-player cooperative game where you're trying to sneak out of a city that has been infected by zombies. A very popular example as well is from the 2014 game Alien Isolation. So this is based on the Alien film franchise, and in this case you are trying to run away from a xenomorph, which is also on the space station with you. Don't worry, there's no scary xenomorph in the video footage. I cut the last 10 seconds of this video because I get killed by it quite unexpectedly, and it's quite gruesome. But the xenomorph actually runs on a behavior tree, and it's looking at everything in the world, and it can only hunt me down and kill me if it sees me or hears me and then comes and gets me. And it actually learns from my behavior. The more I do specific tactics like hiding in lockers, it will start sniffing lockers. I say learn, it's an if statement in the code that says if the player has been in lockers 10 times, start sniffing lockers. But, like I say, it's a very large environment, and you don't know if it's going to find you. You could easily run the other direction and you don't see the alien for 10 hours. So the director always knows where you are, and it's watching where the player is. And what it does is it says to the alien, hey, have you been over there? You know, there might be something over there. Check it out. You're over there, obviously. And at this point on the motion tracker, you're like, oh my god, oh my god, oh my god, oh my god, it's coming, and then you hide. And so what the system then does is it maintains a sense of menace. How long has the alien been in your proximity? Can you hear it? Can you see it? And after a certain threshold point, it goes, okay, right, why don't you go over there, alien? And the alien's like, all right. And away it goes up into the air vent and disappears, and that gives you that brief time to then, oh god, what was the thing I was doing? I need to get out of here right now, and run away and get to the next objective you're trying to complete. And it works remarkably well. It seems, particularly when that game came out, it was heralded for how intelligent the AI is when it's just using existing tricks and tools that are available to developers, but in a unique and novel way. Even constraint programming, which in The Sims of all things, which The Sims people wouldn't really think of as a nuanced AI simulation. You think, well, I'm just creating, I don't know, horrible cake sweatshop factories, or sex dungeons, or murder mysteries, or whatever it is, because people make some really weird stuff when they're playing The Sims. But when you think about every character that exists in your simulation, they have to do a lot of complicated things. And so, for example, on the diagram on the left, this character is going to sit down and watch television. Well, they're going to watch television, that's what they've been told to do. At which point it has to start figuring out, well, where can I stand or sit in order to watch television? Because it's not going to look intelligent if I stand in a room with 5 chairs in it and watch television for 30 minutes. Surely you're thinking, have a seat, you know, take a load off. But subsequently, are those chairs directed towards the television? Is this going to facilitate what I want? And similarly, in the diagram to the right, this is a character who is trying to eat something off of a plate but also drink a glass of juice. Now, historically in older Sims games, the character would actually do this in two completely distinct phases. It would eat the thing on the plate, it would eat the food, and then it would drink the drink. Because the idea that these two actions are concurrent wasn't modeled into the system. And so they built this very rich constraint management system to allow them to understand that you could sit down and drink a cup of coffee and read a book at the same time. Even if the character periodically puts the cup down so it can pick up the book and turn the page. But the idea that these are activities that could be achieved at the same time, and it took a significant amount of work to achieve that. The planning idea, like goal-oriented action planning, has been hugely popular. While I say that behavior trees is arguably the most popular paradigm, the goal-oriented action planning from Fear was also subsequently had a huge impact and is still used in a variety of games today. The problem with goal-oriented action planning is it's bottom-up in its design. As a designer, you have no real influence on how actions are glued together. So a character decides to run over to a table, knock it over, and then gets up and runs over to another table and knocks it over. At that point in time, that might have made sense to the character, but as a designer, you're saying, well, no, that's two actions, that's four actions you shouldn't really have glued together at the same time. But I have no influence on how that's controlled because the GOP planning system provides all these different actions and just gives them equal kind of opportunity to be executed. Hierarchical task network planning, which is also been adopted largely from academia, largely the SHOP 2 planner, which Dana now kind of pioneered over at the University of Maryland in the late 90s, takes this principle but it turns it into macros. And one of the studios that has really embraced this is Guerrilla Games, notably in their Killzone franchise, but more recently their last major release, Horizon Zero Dawn, where we have, it's a post-apocalyptic landscape with robotic animals. And these animals can operate in herds and they can coordinate with one another. And so these macro actions are being used to dictate, excuse me, not only how these characters execute large and maybe complex attack sequences, but also how they can work together as different members of a herd assume roles within their framework. Some of them actually maybe run to safety. One maybe defends the kind of the grazers of the pack, while the more aggressive predators then go in to attack the player and take you out. And you'll notice I haven't mentioned machine learning for the last 10 minutes. And there's, like I said, there's a real reluctance, not to say that it's never really been embraced. In fact, this is a screenshot from Black and White 2, I believe, dating back to the early 2000s, where games such as Black and White and the Total War franchise, the early Total War games, were some of the first titles to explore the use of, say, genetic algorithms and neural networks to control AI characters. But by and large, the rest of the industry never really embraced it. And it's really down to these three tenets here, that the accessibility of the system, how easy is it to modify or tweak an existing system, that the transparency, if an AI is making a decision, can we understand, excuse me, or reverse engineer why it made that decision? And lastly, from a designer's perspective, often neural nets are not friendly because they see it as a black box. They just put the inputs in, the output comes out. They don't really understand how they can manipulate that or exploit it in different ways. But there's a lot of change happening within the games industry within the last 10 years, where we're looking at new applications for AI to create not only just new experiences for players, but to address some of the bigger issues that are now pervasive among game development. And this is where both classical AI technologies, but also new avenues such as in procedural content generation, but also, like I say, machine learning algorithms are having a chance to shine. One of the first avenues that really comes to mind is player modeling, the process where we want to record information about a player in the game and then find a way to reproduce it or analyze it in a way that is useful to us. One of the most well-known examples is in the Forza series. This screenshot here is from Forza Horizon 4, which is based in the UK and developed by Playground Games here in the UK as well. The video is from Forza Horizon 2, because I haven't recorded any footage from 4. So this is me playing a game, and right now I'm playing this offline, and if I remember right, it's my first race in Forza Horizon 2. And every single one of these characters, these opposing racers, are AI players, excuse me, but every single one of them is based on a real person. Excuse me. In fact, some of the markers on their name are actually the markers of my friends. Number 5, I just drove past, that's my business partner. And these are their Xbox gamer tags. And this is saying, hey, that's your friend Matt. Up in whatever position 8, that's actually Mooncake, who I just drove past, actually works on the Forza games as an artist. So I'm feeling good about myself. Number 6 is an ex-student of mine. Now, what's happening is that every time you play Forza, and this has been since Forza Motorsport 5 in 2013 on the Xbox One, that the system is actually recording how you take every corner on the race ribbon. And what it's modeling is the vehicle that you were driving in, the speed that you took the corner, the angle you took the corner, and what it's trying to understand is the expected utility of the vehicle at any point on the racetrack. And then what they do based on this information is they train a neural net. And they train it on Azure servers using Bayesian learning. And the process here is that over a couple of games, it can begin to predict how you would play in this race. To take me out and then maybe not replicate exactly what I'm doing here, but give a fairly rough approximation where you'd say, well, yeah, that's kind of reflective of how Tommy would take this race. The interesting challenge behind it, though, is that the Drivatar is designed so that it will allow for an AI player to represent you on any racetrack, in any game within the Forza series, in any vehicle, even vehicles you've never driven on racetracks you've never visited. So it's always trying to figure out just the expected utility of the vehicle at that point in time, and sort of taking a perfect player and then kind of dumbing it down and tweaking it a little bit to better reflect how you would actually play. Interestingly, there's a whole bunch of stuff that they cut out, because in playtesting, one of the things that the developers discovered, Turn 10 Studios, who originally worked on this for the Forza Motorsport series, is that when you create AI that directly mimics human players, people don't like it, because people don't play games nicely or properly. They started discovering that AI players would drive hard into corners and smash into other players and use them as a buffer to get around corners very quickly, or the AI would cut corners. Why? Because the human that it's based on would do that. In fact, the whole thing of T-barring other racers in a corner, that's how I usually take a lot of corners in Forza. I will drive a corner at 120 miles an hour, just hoping upon hope that that other car is just going to kind of nudge me in the right direction. I didn't even drive to get here today, but nowhere like that. So subsequently, they had to figure out how to tweak and adapt that accordingly. And this has been used in a variety of other games as well, but Forza is without a doubt one of the most recognized ones. Procedural content generation is a huge area of growth within the last 10 years. If you're not familiar with the term, it's the idea that we can algorithmically create content within games. This can range from missions that the player will complete, to enemies that you might fight, such as in the Middle-earth Shadow of Mordor Shadow of War series, where it procedurally generates enemy orcs that are actually these figureheads of the army that you have to kill, ranging all the way up to entire games, or game worlds. And No Man's Sky from Hello Games, down in Guildford in 2014, was one of the most prominent examples of this, where it builds an entire galaxy. And this is actually a multifaceted process where each planet is built based on features and properties of its local star, and then the planet's position in the star system will influence the type of topography and geography it has and the flora and fauna that spawn within it. Now, this is but one of many, many examples, and I am actually going to come back and talk a bit more about PCG later on. One of the more interesting things that's coming out, and it's kind of tied into PCG, is not about players, but in actually making games easier for developers to create. So at the moment, I've been spending a lot of time playing Spider-Man, which is a PlayStation 4 release developed by Insomniac Games, came out in 2018. As a huge comic book nerd, I absolutely adore it. The problem is So Spider-Man, in this case, is swinging around New York City, and this Manhattan in the game is 1/4 scale of real-world Manhattan. It actually works out at just under 5 square miles. And there's lots of buildings, there's roads, there's sidewalks. Someone had to go in and build all of Manhattan. And that's a very complicated thing to do because Manhattan is broken down into numerous boroughs, but which all have their own geometric properties and features. They have specific notable buildings, not only in the real world, but also buildings that are based in the Marvel Universe. And subsequently, you need to make this interesting as Spider-Man to navigate it. The game actually uses a very complicated web-slinging mechanic, where historically in previous games, a lot of them, when Spider-Man shot a web, he could have shot it into the sky, and you just swung through the sky, and it's fine. Here, the web will only attach to the buildings, and it will actually recognize specific points on buildings that are safe for Spider-Man to sling onto. And it's really well put together. So how do you speed this process up? Because otherwise the game's going to take 3 times, 4 times longer than expected because you're trying to build this whole city together. And so there's a really great talk by David Santiago, which was held at GDC last year, where actually the first pass of Manhattan is procedurally generated. What happens is that they built a system where all of Manhattan is broken down into a grid of fixed size units. And what they say is, well, in this region, you're in this borough. And this borough has these geometric features or properties. Maybe we're looking for shorter buildings because maybe we're in Chinatown, for example, or we're up in Harlem. Versus, well, we're in downtown now or midtown, the buildings are going to be a lot higher. And so what happens is it does this initial first pass of creating these rough blocks of city. Designers can go in and maybe tweak a little bit that perhaps suits them and is more interesting to them. And they prepare libraries of textures for the buildings, but also for the roof and the gardens. You can see here there's like gardens and there's air vents and stuff like that on top of the buildings. And what happens is they then run a pass over the entire area, and it will generate this rough work out of, okay, this is going to be this section of New York. Are we happy with this? And this really speeds up the process for the level designers, because then they can go in and they say, okay, well maybe there's too much of this happening here, let's change this building or change that building, so that they're thinking about it not just in terms of interesting places where enemy encounters can procedurally appear, because you can be swinging through the city and a bunch of thugs are maybe having a drug trade up on the rooftop, or there's actually a fight that's broken out in the middle of a junction between the cops and like the demons, which are one of the main villains in the game. And it's like fully, gun-laden combat, but also from the perspective of, is this fun for Spider-Man to navigate it and be able to get from one point to another? And even then, once they build this process where they actually have the buildings and they're happy with them, it goes through another automated system where it actually automatically annotates interesting contact points for Spider-Man, because your web ability not only allows you to swing and just swing across from one building to another, you have a zip ability, which allows you to grab a surface and pull yourself towards it, but there's a launcher where he actually uses both hands, launches himself to a point on, say, this corner, and then launch yourself off it at speed. The system needs to be able to know these are safe points for Spider-Man to contact, but also you can run along the walls. So you might swing down onto a building and then start running perpendicular to, which is running across this particular wall here, but there might be fire exits in the way. So it figures out interesting places to put these fire exits so it's not convoluted, because then Spider-Man actually can automatically hop around them as part of this kind of free running ability that you have. So all of this is being automated to cut down on that, on the human labor involved in this process. It's still buggy at times, but it's allowing them to really cut down on that overall development time. Another big part in maintaining games in the long run is actually a huge boom in data science. Being able to capture information about how people are playing games, and then from that, make intelligent decisions about how games are going to change. Pretty much every major AAA publisher now has a data science team somewhere in the company, whether it's Activision Blizzard, whether it's, I think actually Activision Blizzard has their own unit, and I think King has their own unit, and I think maybe Activision does. I know Electronic Arts has their own team, and there is a number of teams that work at Ubisoft. And one of the reasons for that is that, particularly in companies at Ubisoft, and particularly games like Rainbow Six Siege, this is an online shooter game, a very tactically coordinated game. They're constantly looking at the state of that game and what players are doing within it, because it influences how the game is updated. In this game, this is a tactical shooter where players are breaking into a defended and fortified structure, and players take on particular archetypes or roles. They actually can play as one of a variety of heroes, hero characters in this case, where each of them has a specific ability that can counteract the current state of the world. For example, the gentleman in the middle, that is Sledge. He's also the one Scottish character, and funnily enough, he was my favourite character at launch. He has a sledgehammer which can breach surfaces and actually smash through walls that other players cannot. Ash, the woman on the far left, she has a grenade launcher which is also able to destroy surfaces but from a distance. And subsequently, Valkyrie, she is able to deploy special cameras in other locations. All of these characters are built to counteract one another. For every one of them, there is another character that can undo their effect. And what they do is they pay, at Ubisoft, they're paying a huge amount of attention to the pick rates of these characters. Who is using this character? And on average, are they winning? And are they even getting kills? Are they being conducive towards that team winning that match? And this isn't just in Rainbow Six, particularly MOBAs, multiplayer online battle arenas like Dota 2 and League of Legends. This is a huge part of what they do behind the scenes. And this is what influences so many changes that happen with every patch or update that is made to these games. They're looking at how people play the game, and maybe they're realizing, oh, this character is actually too strong. We need to nerf that character or remove some of their competence. Or this character is just not being picked. So we need to try and buff that character and make that character more interesting for people to try out. Sometimes it doesn't work. And I know particularly as a long-time Siege fan myself, there are certain characters that nobody plays anymore. And so periodically, the company is going through this phase of trying to completely rebrand and rebuild these characters. Another huge area in recent years, and this is particularly where machine learning has had a lot of impact, is in animation. So typically when we think about animation, people are creating, we're hand creating animations. Maybe we have an animator or two on the team, or you have a motion capture studio where you're actually capturing this data from real life performers, which nonetheless still needs to be cleaned up and prepared to be put into the game. But the hard part is gluing all these animations together. And so even something as simple as my standing around here, waving my arm around and walking back and forth, these maybe are multiple animations that have to be glued together at specific points. And this is the protagonist of Hitman Agent 47, just walking around in an environment. And that might require multiple animation types. So there's going to be an idle, there's going to be maybe some turning and banking behavior, but also just casual walking. And there's an animation tree that is built to figure out where those animations blend into one another, and this way it transitions from one animation to another. This is a huge amount of work. It's very difficult to get right. It's even more difficult as the number of animations increases. And so IO Interactive and Ubisoft, I know, have put a lot of time and effort into this. This version here is actually using a really simple reinforcement learning policy to figure out how to blend or select the animations and steer the character correctly at runtime. And it uses a really simple, what is it? I think it's a simple greedy policy, if I remember right, which works remarkably well. But this has been also applied at Ubisoft. They're looking at, they have a technology called motion matching, where one of the things it does is they automatically are able to look at all the animations and calculate the ideal blend points between them, so a human doesn't have to go through that process. And it allows the animators to focus on, well, their job of making great animations. Even similarly, there's also other applications or technologies been applied for this. Doom, the 2016 version, does an entirely mathematical and finite state machine based approach to this, which works remarkably well. But even recently, Ubisoft have been exploring this themselves at their LaForge R&D unit in Montreal, and there was some really exciting work shown at SIGGRAPH this year from a team of researchers at University of Edinburgh, where they're using deep learning to completely figure out not just the particular animation, but also scale that animation in accordance with the reality of the environment. So for example, having my character sit in different types of chairs, whether maybe there's arms to that chair, the chair is bigger or smaller, it can use that same animation and then figure out at runtime how to actually blend that animation to fit that geography respectively. Excuse me. One of the last big things that's really coming out in the last couple of years is automated testing. Games are getting bigger. Games are becoming increasingly difficult to monitor all of the bugs that come about. Game development is often a very anarchic process where the features are coming together. All the features that are required of the game are being built as quickly as possible. We're getting it to that point of maturation where you think, this is the game's fun. And then it all breaks because you've tried to put all the art and the animation in it and all these other bits and pieces, and the game begins to become, well, a lot less fun to get up to that last hurdle at the end. And this is a huge problem for very, very large companies. And so one of the new things that's coming out is, can we actually build AI that tests a lot of the game for us? Now, there are a lot of human testers that exist in the games industry. Quality assurance is a big aspect of the industry. It's a huge challenge. But this allows for the QA teams to focus on quality that is particularly, that is not necessarily functional, but things that maybe players will spot in a way that a machine cannot. And Tom Clancy's The Division 2, actually both Tom Clancy's The Division games have embraced this wholeheartedly. So this is actually an AI-controlled bot that's been told to navigate a region of the Dark Zone, which is a player versus player or PvP area of the game. And it's just been told to navigate the environment and make sure you can successfully get from point A to point B without it breaking. And that the mission triggers are activating accordingly. Excuse me. And this is a process that by and large comes while the Division is made a massive entertainment in Malmo in Sweden. A lot of the bot development actually came from Ubisoft Reflections in Leamington. And what was happening is that these bots are being created to explore whole parts of the game, make sure that mission or level is playable. Because if it isn't, then players are going to spot this. But there might be weird edge cases that players might not even find, and so they exhaustively let these bots sit on console builds of the game. I think this is actually playing on an Xbox One, a whitelisted Xbox One dev kit, and it's just playing the game representing the player in this context. Similarly, there is also cases where they have server bots, because this is an online game. Excuse me. And one of the things they're doing there is, can they aggressively monitor server traffic and see whether or not a player is able to successfully join the game, play around a little bit in the world, and then disconnect? What impact is that having on the load in the server? Can 20 players all log into the server at roughly the same time? Is this going to cause an overhead somewhere that's going to diminish performance for other players? Or is it going to increase the load times for all these new players coming in? And so they've really invested in these tools, and they're continuing to develop them and expand them. And it's becoming a huge part, not just of the Division 2, but also other Ubisoft projects as well. So these are some of the really cool new avenues that AI is being employed within this. This is like the last part, the third part of this talk, is the open challenges, like other cool open avenues that maybe aren't really being explored yet, or by and large not being explored in primary game production. What about, and these are largely coming from academic research, but also some now of it also from corporate research too. And speaking as someone who's been in the academic world for a very long time, too long, there was a lot of interesting phases we went through in academic research in the context of games. So I joined this community by and large about 2005, 2006. And when I started there, and I'd say game AI research has been an ongoing thing since maybe 2002, 2003. And at the time, these were the two big areas. Games as benchmarks, the idea that we can use a game to test an AI method, and then we could maybe solve a game or genre of games, and this would allow us to ascertain the validity and competence of a particular methodology or algorithm. And we're seeing this with OpenAI playing with Dota 2, we can see this with Google DeepMind experimenting with StarCraft, and also other companies like Facebook, which has actually been competing in the Doom competition, which is a game in which you try to play Doom, but entirely from visual information in the world. We don't give the character any state information about where demons are. It actually just explores the world purely from what it can see. But also, Microsoft has been working on Project Malmo, which is their R&D coming out of Microsoft Research in Cambridge. And Katja Hoffman's been running this project for a few years now, where they're using it to evaluate reinforcement learning algorithms. Can we build RL algorithms that can solve specific problems within the world of Minecraft? And naively, there was this assumption that academic research could improve game AI. And one of the interesting parts of this was that we were really interested in reinventing wheels, or inventing new hammers to hammer nails that didn't exist in the games industry. And I can speak from experience. I went to a couple of these meetups where we had people from the industry and people from academia in the same room, and the academics are saying, hey, we've got this really cool reinforcement learning algorithm, or this evolutionary algorithm, and it can do X and Y and Z, and we can build these cool non-player characters. I was one of them. I was making these systems. And then we talk to the game developers, and they go, nah, we know how to do that. That's a known quantity. Here's the things that are really impacting what we're doing right now. Can you maybe help us address this? And you're like, none of us is looking at that. That's not an interesting problem. Yeah. And so, yeah, it was just kind of ships passing in the night. No one was talking to each other. No one was really communicating. This has actually changed significantly in the last few years. And particularly in the United Kingdom, we have the IGI group, the Intelligent Games and Gaming Intelligence Consortium, which is ran out of Queen Mary University in London. And what they're doing is they're actually getting PhD. It's one of the largest doctoral training centres in Europe dedicated purely to gaming research. It used to be predominantly AI. It's now broadened its horizons a little bit. But what they're often doing is they're partnering up their PhD students with people from industry, with companies who have particular challenges or problems they're trying to solve. Are they going to solve them? Maybe, maybe not. But this is actually achieving a much greater synergy between these two units than ever before. And really, at the moment, some of the coolest stuff that's coming out of procedural generation and computational creativity is emerging in this space, not just procedurally generating solutions to problems in games, but the idea of computational creativity for games. Can we build systems that just make entire games? And particularly, I shout out to my friend Michael Cook from Queen Mary University, whose work Angelina is actually one of the most prominent examples of this, where you are building, it's actually a system that designs its own video games. By and large, they're not very good. Mike will probably be the first person to attest to that. But the process of how it's going about building these games and what those games mean to that system as its designer are really interesting. Also, a shout out to the General Video Game AI competition, which is also ran out of Queen Mary in London. So, one of the interesting things that's coming up now is corporate research has kind of taken over the academic research. Like I said, this idea that we're going to try and create AI players that can defeat StarCraft. This is something that's been bubbling within this community for 10, 15 years. There's 2 competitions already dedicated to this, the StarCraft AI competition and the StarCraft AI competition, the student StarCraft competition in AI, the SSC AIT, I always forget what it actually stands for. But these are been going on for a long time, and then subsequently you're dealing with very large corporations with huge amount of compute power and resources behind them solving these problems that academics have been trying to do for years. How do you challenge that problem? And I had a discussion about this a while ago with Julian Tegelius, who is a assistant professor at New York University and one of the kind of figureheads of the game AI research community. And we agreed on this idea of leaning into the weird, doing the weird and anarchic research that large corporations aren't going to try and do. Can you go and do something that's a bit odd or a little bit more experimental? Because it's not for them in terms of exploring algorithm applications and design. This has huge value. For corporations, it's not really something that they're going to be interested in because it's harder to sell. Selling the fact you've built the greatest AI StarCraft player in the world, yeah, you can do that. That's not hard. Not to diminish their PR team, but yeah, you can sell that. Selling other weird anarchic stuff that you're doing in your research lab, well, maybe not for corporate, because they're having to account to shareholders, but certainly for academic research, there's a lot of value in it. And this is actually a table from a paper published in 2015 about different ways in which AI can be used in games, and what kind of pattern or design pattern can we use? Can we observe the AI's state, and that gives us strategic information? Can we treat an AI as a role model where we want to learn from them? Or can we edit them such that an AI is a character that we want to manipulate or author to facilitate a gameplay experience? And then the traditional thing of adversaries and villains, whether it's a symmetric or asymmetric opponent within the game, or even just if they're a spectacle, are they just something you want to watch? Are they just something you want to enjoy seeing within your game? And I'd say certainly there's a lot of ongoing research right now in areas such as automated narrative. I used for this particular example Facade, which is a very old project now. I think it's over 10 years at this point. But it is without a doubt, one of the most well-known examples of procedural narrative that has came out of the academic community in many, many years. If you've never played, anyone played Facade? Just out of curiosity. Anyone heard of it? All right, cool. It's got like 10 million views across YouTube for all these different Let's Plays. And the whole premise of the game is that you're coming to visit this couple in their apartment. And it's clear they've had an altercation of some sort before you turned up. You don't really know what's going on, but they're not happy with each other. And you interact by actually typing into the keyboard and talking to them. And they respond to what you're saying to them accordingly. And there's numerous ways in which this can pan out, because the whole idea is you're coming around for dinner. You can be kicked out of the door mid-dinner because you've upset them. You could wind up sleeping with either of them. You could upset both of them and never be let in the front door. I think if I remember right, there's one potential outcome where one of them gets murdered, but I don't think I've experienced it. And this is why it was so huge on the internet, because people were doing their own playthroughs. Can I get this situation to occur? And because it's reading text input from the keyboard, people are experimenting with what are the terms or phrases that these systems are recognizing. And this is far from a solved problem. This is just arguably one of the most well-known examples. And it's a body of research that's continuing to grow in more recent years, and there's now even game studios such as Bossa in London, which have been really interested in trying to make this an applicable technology that you could actually put into your games and make this a kind of fun and engaging interactive experience. There's also the idea of data games, like can we establish ontologies of knowledge from real world data and then use that to create a game that is really weird or kind of daft? And the example I've used here is Data Agent, which was by Gabriela Barros, who's a PhD graduate from New York University. And this actually scrapes Wikipedia, if I remember right, or a similar format, to create an ontology where it then builds murder mysteries or other types of mysteries where it's like, hey, I want you to figure out who it is that's killed this particular famous person. And based on the social connections that they found in these data sets, it will then actually establish a set of suspects that it could be that was the murderer. And then it will generate interesting narrative choices that could occur, or how they would react to your accusations based on an expectation of how that character might behave. You can actually download and play this. It's on the itch.io, and it's really great fun. Another example that comes to mind is A Rogue Dream, which was made by Michael Cook, who I mentioned earlier from Angelina, which has never been made public, and it was with good reason. A Rogue Dream was a system that was designed to create gameplay experiences by Google milking. Anyone heard this term before? Okay. So if you go into Google and you start typing in a phrase, why do cats, and then the autocomplete kicks in, Google milking is the process of actually scraping all the autocomplete off of it and then using that as a means by which to create a knowledge base of interesting things or facts about cats. Why do cats cough up hairballs? Why do cats not like having baths? Why do cats hate dogs? Subsequently, the game is creating this really simple game where you're playing as a cat and you score points by coughing up hairballs, but you have to avoid water and dogs. Now, one of the reasons that Mike never released this game is that there are very real issues that emerge when you don't constrain that kind of system when it has access to the internet. Humans are not particularly nice people, by and large. You all seem great, but the world at large is a bit of a horrible place, and the internet is this weird mirror or reflection of our darkest perceptions of reality. And so when you start bringing up elements of religion or race into these Google milkings, you start getting some very weird and horrible things, and this system was making games around it. And subsequently, I think he made the right call by realizing that there's a big argument there that this is a computationally creative system. Sure, it's making those decisions on its own, but that will reflect on him as the original author and creator of that system, and so he decided to never release it. But nonetheless, it was a very interesting body of work that he published a couple of times, discussing both the merits of what it created, but the risks of what it was generating in turn. Coming back to procedural generation, there's some really interesting areas here to explore. Firstly, one of the big things that's happened is that historically, if you look at a lot of existing academic research, as well as some applications in video games in the industry, it's often with this handcrafted approach where developers are building a model or a representation of an existing problem so they can procedurally generate new versions of that problem. So Mario levels, always a popular one in the academic community. You know, if you ever Google Mario AI research, that like so much out there. But one of the interesting things that was emerging in this space is that everybody's creating procedural generation systems that mimic Mario levels based on that author's understanding of what Mario levels are. And I published a paper a couple of years ago where I looked at Mario Maker, which is a game that was released on Nintendo platforms. In fact, the sequel came out on the Nintendo Switch, I think last year, where this was the same level creation tools were given to humans. And so I was like, what do humans create? And what they create is absolutely bonkers and absolutely nothing like Mario levels, by and large, but they're fantastic and they're really interesting to play. And so the argument I was making was, we're running on this expectation that we know what Mario levels are. Maybe we should try making things that aren't Mario levels, experiment in that. But that's a whole other kind of deep dive. What we're seeing now is machine learning being used to reverse engineer the secret sauce. So instead of having the designer or developer come up with the rules of the level generator, what if the machine learning system just looked at the levels itself and it builds its own implicit understanding of what those levels are? And this video here is actually a paper which was led by Vanessa Volz, and this is evolving Mario levels using generative adversarial networks, where there is a system, if you're not familiar with the term, so a generative adversarial network is broken down into two separate neural networks. A discriminator, there's a discriminator and a creator. The discriminator is actually trained to look at Mario levels to a point that it can understand what a Mario level looks at with a very high level of confidence. It looks at this level and it goes, yeah, that's a Mario level. No, that's not a Mario, that's a Mario level, but that one isn't a Mario level. And it trains against hundreds, if not thousands, of these snapshots. And then the other network is trying to create levels that can fool the discriminator. So the generator is creating these new networks, these new levels, sorry, and then it's hoping that it can fool the discriminator. And if it can create a level that fools the discriminator, that is then a completed level that it releases. And this is some of the levels. I think there's actually been some follow-up work to this. This is from 2018. But you can already see Mario-like qualities in this. Not all of them are perfect. And in fact, some of this is actually deliberately ripping off this. That's level 1, 2 of Super Mario Bros. I know that for a fact. So you're seeing specific features that if you've played a lot of Mario levels, you're, hey, that looks familiar. And that's because it's developed that implicit understanding. And one of the things they do once those levels are created is it then lets a bot play them to make sure they're actually completable. Because at that point they know it's a satisfactory level to release. But beyond that, can we generate artifacts within games that have a sense of meaning or purpose? So this is the winning player from the 2019 Generative Design in Minecraft competition. I think the developer was codenamed Phillips PCG stuff. And this is, in the competition, the idea is that you're given a plot of land on any Minecraft map, and it says, right, build me a settlement, build me a structure. And this is one of numerous structures that it built. And what's happening is that as a judge, and I can speak from experience, I was a judge on last year's version of the competition. What we're grading is not just the functional elements. Does this settlement make sense? Does this settlement respect the local topography and geography? But also, is there a sense of history within this town? Do we understand that maybe that's why there's certain structures in certain part of the town? Maybe the building materials have changed in one part of the town from the other. Can we detect maybe a kind of a sense of social class or economy that exists within this town? Is this town safe? Is this town going to suffer in the case of a natural disaster? Or is it going to be safe from monsters if it was ever to be attacked? And it's really taking a lot of interesting problems in city planning and then applying them to creating Minecraft structures. And if you're interested, I would definitely look up the GDMC, because the 2020 version of the competition is just about to be announced, and they're always looking for more people. Nearly there. Excuse me. One of the more interesting problems, both in corporate and academic research, is the idea of community and enforcement. This really ties into a lot of natural language processing and being able to understand intent of people communicating to one another on the internet. As I mentioned earlier, people on the internet aren't the nicest people in the world, and people on the internet in gaming platforms are like one step worse by and large. A lot of comments about my mother's lineage over the years. If you don't know what I'm talking about, good for you. But this is a space where children are playing. This is a space where particularly people who are, for example, I was going to say definitely women in this space get continually harassed for no reason, and also people who are perhaps LGBTQ or whatever else. There's lots of reasons why people will find an excuse to harass you on the internet, sadly. Can we find a way to better protect these people, or just protect everyone, so everyone just has a better experience? I have a solution to this. I just don't allow voice or text chat to anyone that isn't a friend of mine on Xbox. Which means that every time we go into an Xbox party and one of my friends invites one of their friends, I can't hear them. And then they say, why can you hear this? It's not personal, he just doesn't like talking to new people. Because I just can't be, I'm too old for this, man. I'm 35, 36, how old am I? 36. I can't be dealing with that. So no, but this is really valuable, and this is actually one of the new community updates that was released on the Xbox One platform. I think it was late 2019, I think it was about October time, where this is now, they're actually using filtering and natural language processing to capture offensive messages from other players, and then saying, well, maybe you don't want to see that, and based on your parental control settings, maybe you never see it because we don't want our children to have to put up with this nonsense. But as an adult, it says, well, that's hidden. Do you really want to see what they said? And then you take that gamble. You're like, all right, I'll have it. Oh, I regret that. Why did I even bother? But this is a really valuable element, and certainly there's other companies, notably Spirit AI, which is based in, I think it's New York and London. They've also spent a lot of time building these tools that are more extensive to other platforms, not just within the Xbox ecosystem, but whether other companies making their online games can embrace these tools and not only capture this horrible behavior, but also identify to the player, hey, this other player is repeatedly harassing you. Will we block them for you? Yes, please. That sounds like a great idea. Okay. And then you no longer have to deal with whatever that person's saying, and they're just shouting into the ether. Sadly, they're not learning their lesson, but you're getting to have a better experience overall. Some more recent work that came out. This is actually, well, this is bunnies. Lots of bunnies. These are all physics simulations. The blue balls are being used to deform rubber bunnies, and you can see that they're all getting mishmashed in a variety of different ways. And this is a body of research that was published last year, Subspace Neurophysics, which is a collaboration between McGill University and Ubisoft LaForge. What this is trying to do is essentially create fast data-driven physics simulations and running them on neural networks. The reason for this, physics computation is really hard. It takes a lot of resource on the CPU and in memory in order to pull this off. However, you might not be able to see this, but this is currently consuming less than 2.5 megabytes of memory across the CPU and GPU, and it's running at about 115 frames per second. This would be very difficult to do if you were actually replicating this level of physics accuracy for this many objects at one time in a traditional physics simulation, because the GPU in particular is going to be getting bashed with a hard number of computations to achieve this physics simulation accurately. So what they do is they're creating neural nets through principal component they use principal component analysis. They reduce this physics simulation to a certain number of variables and then train a neural net to see if they can reproduce the expectation of what that physics simulation will do at this point in time based on this action occurring. And it's still got limitations, because ultimately the physics simulations that it can generate, it can only replicate things it's seen before. It can't predict new physics simulations. But there's some really exciting examples that's coming out of this. We can we've got lots of bunnies. I focused on the bunnies because I thought bunnies would be great for the presentation. But there's a nice YouTube video that this clip is taken from. They show you cloth and material. So the idea of a sleeve moving up an arm or a cape on someone's back, and being able to replicate that and simulate that with a very low CPU and memory load, which is very, very exciting as we're trying to build these larger and more complex games. And yeah, probably the last topic that I could think of was texture upscaling. Deep learning is actually being used in two specific ways here. First of all, as ray tracing is becoming increasingly popular on modern graphics cards, this DLSS, deep learning supersampling, is being used in order to replace traditional anti-aliasing for graphics cards. One of the things that happens when you're rendering games at higher resolution, there's a possibility that you get fudgy edges on objects, particularly as corners and what have you, and even more so when you see it from a distance. And anti-aliasing was designed to address that. DLSS is being used to see if you can upscale and address the anti-aliasing to even higher resolutions. So maybe you're rendering the game at 1080p, but through DLSS you can actually upscale it to 4K, and it's achieving the same level of anti-aliasing. But the problem is you're having to train those data sets to achieve it. One of the more interesting and kind of homebrew productions is actually what we're seeing here. This is video footage, of an emulated copy of Metroid Prime 2 Echoes, which came out in 2004 on the Nintendo GameCube. However, this is actually running on 4K textures that have been created by a hobbyist, a homebrew developer, who has taken the original textures out of the game and trained a neural net. And actually there's actually now libraries and tools that are available on the internet to do this. Can I upscale that texture from the original resolution that it had, maybe 512 by 512, running on a Nintendo GameCube, to 4K to run in my emulated version of the game? And there's a huge amount of work being done in this area. There's lots of communities really excited about this. I've seen some really exciting work where people were upscaling like Final Fantasy VII, taking the original screenshots on the background images from Final Fantasy or the old Resident Evil games and upscaling them. And it's turning into this little small economy of its own, where all these developers are working together to try and clean up a game so it's still fun and reads well on modern hardware. Because playing a lot of these older games on emulators with a 1080 Ti graphics card, it looks horrible and fuzzy because the textures are the issue. The actual rendering isn't really a problem. And this is this has been a very broad talk by and large. What I wanted to do is to show that not only the type of technologies that are being used, but the unique challenges that are being faced within the games industry. And there's still a lot of work to do. There's some really cool work coming out of corporate and academic research. And I think there's some real potential. As the democratization of game technology has broadened, you now have academic researchers who are game developers. You have students who are able to make their own games and showcase their potential, not only potentially to go and work in a games company, but also to maybe go and conduct research for a research lab somewhere. And I think there's a lot more exciting experiences ahead of us, but it isn't just about the games we make, it's going to be about how we're making those games and making life for developers as amenable and as fun as possible, particularly as the scale and complexity of these games increases. And yeah, that's it from me. Thanks very much for listening, and I think we'll be open to questions as well. Thank you. Yes, sir.
Do you think we're going to see more focus or more efforts in using natural language processing in game development? For example, to make conversations between NPCs and players more impactful or more natural?
Yeah, so the idea of using natural language processing, I think the acceptability of approaching that kind of complexity of task has changed. One of the things I mentioned earlier was like all these R&D units that are now emerging, and a lot of these tasks that have often seemed really exciting opportunities that maybe we might get around to having a look at. These are now things that real people are interested in. And when Microsoft are looking at it in one way or another, against Spirit AI, we're also actually doing a bit of natural language processing with a separate character system as well, which allowed you to have a more nuanced and rich textual-based communication with actual in-game characters. I can certainly see this going forward. I don't think it's there yet, but I would really love to see in the next kind of 5 years someone fully embraces this idea and puts it into their game and takes that idea of facade and with more contemporary natural language processing technology, allow you to have richer and more interesting experiences with players. I think ultimately it comes down to the type of game they're going to make, because fundamentally this might remove the authorial intent of the original designer and them having complete control over what those conversations could be. Like, imagine you're playing Mass Effect and you can just go off in some weird tangent talking about the character's backstory or whatever else. But yeah, I would really love to see something like that in the future. And I think we're getting there. Yes, you shot up with great verve there. So
These are really exciting applications for sure, and as like art, to me, games are kind of like art, so they really expand possibilities. You say. Sometimes get worried when on some of these slides because we've all been like little children who play games like way too much, right? And with these technologies, one thing that could happen is your, let's say, procedural generation. Now your game doesn't have a campaign that ever ends; it can go on forever. Or with like your data science optimization, they know the right things to show you to keep you playing longer and things like that. So how do you think as someone who's been in the industry, how do you think game developers or like companies have felt that like growing sense of responsibility of this like newfound power? Is there any discussion of that?
How long have you got and how many years do we have? Yeah, responsibility has never exactly been, particularly in the AAA industry, one of their strong suits. Particularly if you've seen a lot of the recent discussion around loot boxes and monetization. This, for me, is actually a very real concern because we're dealing with, fundamentally video games are often about the psychological manipulation of a player to keep them engaged in that process. You can actually go back and even look at the basic compulsion loop theory that is built around games, and games are ultimately psychological systems that try and keep you engaged at numerous levels, and exploit that in different ways.
Can I interject there? Like,
yeah.
I hope you don't call them that, because like I do think there's power. Let's say the game facade that that game can communicate a lot of interesting things. I don't want to say that games are ultimately psychological, traps or something. And I hope you don't see them that way either.
Like, as someone who plays far too many of them, I can see past their flaws, but fundamentally that is always, and as someone who makes them myself, that I'm trying to get you hooked. What I love more than anything is I create a game where someone's like, screw this noise, and they walk away, and we're showing the game at an event 5 minutes later, and they're like, can I have another shot? I'm like, yes, please, yes. Because that's going to be money at the end of the day. Now I'm dealing with this on a much smaller scale, on the person-to-person places, yes, come back, play my game. But when you're dealing with these larger corporations, I actually did an episode about this not that long ago on a YouTube show about the risk of this being applied to monetization. And I know this happens. I just can't see who. That there are companies that are trying to edit their microeconomy on a per player basis. So they go, would you really like to spend money on these things? Let's give you more of those at better deals or better offers, and we completely change. But those purchases are potentially going to have an impact on the larger design of the game. Have you got games where the meta of the game and its economy are being shifted to extrapolate more and more money out of you? Yeah, that's happening. I think it could happen on an even larger scale. I think we need to be prepared for that and understand that these are issues of data privacy, but also how the responsibilities of game developers in utilising that information. Already you've got player modelling in a variety of different games, and thankfully there are regulations that say, right, well, you're only going to keep the pertinent information here, but if the pertinent information is your purchase history, how can we trust them to use it responsibly? One of the things that I found a bit disappointing is there was a lot of discussion recently, in fact even in the government, about loot boxes and microtransactions and monetization. We're not having the discussion we need to have of what happens when this information is utilised on global scales to manipulate players to spend more money in ways that, like on a government level, they're not even thinking about it right now, because they're like, loot boxes, what's that? What's an Overwatch, sort of thing. So I think these are really big issues down the line. I think knowing the video game industry as it is, what's going to happen is some company is going to do it, and then everyone's going to find out, and then they're all going to be unhappy about it, and then that will explode, and then we'll maybe see if the thing we don't want is regulation, because that will actually maybe impact and impede development in ways that would actually be useful, but self-regulation isn't exactly our strong suit. So the future's morbid. Sorry, you had a question here.
Yeah, I think I actually have two, which are basically follow up to the previous two, I think. So I'll go in order. Like first, a comment on this one. Like I mean, like I also think like especially indie game developers have objectives when they make games which are not just getting the player hooked necessarily. Right? Like I think Jonathan Blow is like very critical of game developers whose objective is like that, and he tries to instead like make games which I don't know, like try to transmit a message, and it's like a finite game, like you will finish in 3 or 4 hours, but you know you feel like you learn something. Or so I mean that was basically a comment, but you can comment if you want. Like my main question was also related to the previous one on natural language. Like have you heard about AI Dungeon?
Yes.
Like okay, like because I think it's like a great example. I mean it's like the best example of natural language in sort of a game that I've ever seen, I think. And I think it's like a really cool experience of seeing like a system where you have like a really flexible input, but it's also giving you like novel things, and so you feel like you're creating something new that maybe nobody has seen before, because it wasn't created by like a person necessarily.
Yeah.
But you also have like an input in it, and I think like it's
So there's a couple of responses to that. One, like AI Dungeon was great. I had a lot of fun when AI Dungeon 2 came out, like not that long ago. I think my first time I played it, it was something to do with I went into a forest and there was a dragon there and it was ready to eat me, and I talked my way out of it, because immediately I'm put into these environments and you've got this complete textual control over what you're asking and how you're interfacing with that world. And so I was like, what have I got in my pocket? And the game's like, oh, you've got water and a flapjack or something. And I'm like, okay. And I just said to the dragon, do you want a flapjack? It's like, okay. And it completely derailed the entire like this conflict that was about to occur. Like, this is fantastic. We have this really rich kind of cause and effect that's being modelled here, but there's also limitations in it still to this day. I think one of the really exciting things that could, one of the biggest problems still is the cost of maintaining systems like that. So AI Dungeon only ran for a very short period of time because the cost of hosting it was proving problematic for the researcher whose name sadly I've forgotten off the top of my head. But it required that existing to build the GPT-2 model, and then host it online, and that has got a recurring cost that you've got to find a way to make that acceptable for a developer to continue to invest that money. So that's one big problem. Similarly, it comes back to the StarCraft II problem. Not everyone's going to make AlphaStar because you don't have $20 million in your pocket and lots of existing player data. One thing that I think is really cool that ties back to this is, can we curate interesting scenarios for players to explore from humans? There was a really exciting body of research that was coming out of Georgia Tech University under supervision by Mark McDell. And one of the things he was doing or him and his PhD students were doing was asking people the same to tell stories around a certain scenario, and then reverse engineer from that the graph of all possibilities within that scenario. So kind of taking the facade idea, but giving it to people, and also kind of leaning into that data game idea of, oh, and I think the example, I used to have that on another talk I gave, was imagine you went on a date to the cinema. How many different ways could that pan out? And it would range from, we never made it because the car broke down, or the guy never came to pick me up, all the way to, we didn't have a great date because neither of us liked the movie. Or, we had a great date and we didn't bother watching the movie. And what they were doing was they took lots of these handwritten responses to this question, and then from that they were able to process all these different possibilities and actually built a graph that of cause and effect. Essentially like what Telltale do with their story-driven games, where they build up a fixed graph of possibilities that you can do. They were generating it from human experiences. And I thought that was really exciting because you have a level of authenticity to it that you only get from asking people, but also weird stuff that could only happen when you ask people, because it maybe has this particular nuance that maybe even just from monkeys and typewriters you maybe wouldn't get. So that was a very long-winded answer to your question, but I think we maybe got there. Yes?
Do you use AI to sort of tailor the game to each individual player to maximise their fun or how much they play? So for a racing game, the AI car will always be half a second ahead of you when you first play it, or something like that. So even if I'm a rubbish racer, I'll have the same amount of fun as someone who's really good.
Yeah, I mean, a lot of director AI is about trying to keep the player in the zone, by and large, and creating an interesting scenario. And I think combining that with player modeling is an interesting avenue to go forward with. That it's a very fickle issue because you're trying to maintain that cognitive flow. You're trying to get that idea of, I'm in control of the situation, and while it's challenging, I'm still having fun. And as soon as it feels like the systems are being too harsh upon you, or they're too relaxed, your overall engagement in the game is going to diminish. Excuse me, racing games in particular come to mind because they really use rubber band. AI historically, where you're in complete control and then suddenly at the last minute, Luigi comes screaming past you. Yeah, I think it's something that we could hopefully see more of. I know that a lot of AAA games like Far Cry and stuff like that use a little bit of simple analytics of reading what the player's doing at any point in time to try and guide new experiences that come towards them. But the richer the models are, I think the greater the play opportunities can emerge from that. Yes?
So, sort of on that thread as well, talking about player modeling.
Yeah.
I was wondering first off, sort of what are the sort of techniques which are being used currently, both in academic research and commercially, for player modeling? So like forms of invitation learning or industry reinforcement learning or whatever else. And the other thing I was wondering is sort of what level are the models that are being learned? What level are those representations? What can you do with them? So aside from just looking at how a player races and then just simulating a run of them, being able to, for example, allow an AI to use information that's learned about that player to either cooperate or be adversarial to them, and maybe even extending to sort of real-time modeling. So say you model players having different states of mind and things like that. So essentially, first question, what is the sort of technical approach, and second, what is the sort of level of representation? What can we do with it?
Okay. So at the moment, there's only been a handful of these applications that have actually made it into commercial games. Supervised learning, by and large, the way forward. So we saw Forza, like I say, is Bayesian learning. One of the other notable examples that always comes to mind is case-based reasoning, which was used by Iron Galaxy it was Iron Galaxy Studios for the second season of Killer Instinct on the Xbox One. They have a system called the Shadow Mode, where within 3 matches the bot can replicate the player's performance. And what they're doing is, on a situation by situation basis, recording exactly what that player would do at that point in time, And this is really important in the context of that game because it is built on combos. Players are able to build these really multifaceted combos, but also understand when they can break another player's combo against them and counteract it. And that actually worked remarkably well for them, but the level and granularity of that data was very coarse. It actually worked out okay for them because fighting games are relatively small domains. You're only really interested in the mechanisms of that combat. It's not a larger world they're trying to deal with. Interestingly, one of the things that I saw coming out of Seed, which is Electronic Arts' R&D unit, is they're trying to use imitation learning, not just as an opportunity to model the player as they're playing, but also to bootstrap AI creation in-game or to test the functionality of a game. And so there's some really preliminary research coming out of that unit where they're using imitation learning to take existing playthroughs by designers and testers and then see whether or not if they can tweak and improve that and refine it. And I think what they are interested in is trying to take the approach from AlphaStar, because AlphaStar's huge problem is you need all that human player data, and if you're making the game, you ain't got it. Can they achieve simple imitation learning to maybe bootstrap just enough of that behavior and then maybe use reinforcement learning on top of it to try and refine it and improve it? That seems like a really cool avenue going forward. I guess it's going to be a little while before it actually makes its way into any products, because at the moment Seed are doing lots of really interesting research and none of it's made it into their games yet. So I think this generation we might actually see some of it bear fruit in the titles out there. Yes?
Yeah, hi. So my question is more about the industry and
Uh-huh.
rather than AI. So as I understand, you've done kind of like a bunch of different quests for different video game companies.
Couple,
What
yeah.
I wanted to ask is, what is it like having to come into a new company which has built their own frameworks and like having to learn that every time rather than like working long term in a company? Because I mean, even learning something like Unity or Unreal Engine takes time, right?
Yeah.
I mean, if you can say a few
It's
words about that.
a lot of the companies I've worked for, maybe 2 or 3 companies now, all relatively like hands-on in the office actually writing code for them. Predominantly all in, is it 3 or 4? 3 in Unity, 1 in Unreal. And yeah, they're interesting problems because you're coming into the fore, and often a lot of the time my job is either to build the AI system for them or fix the existing one. And yeah, there's always that interesting process because you've got to maintain that communication and say, right, this is what you want me to do and this is how I'm going to go about it. And you're going to go through that process of I'm going to break everything for a bit. And then it's maybe going to get better. And you're like really holding on like, it's going to get better, it's going to get, and then thank God it usually pans out. Yeah, like it's the case with any software development project by and large. I used to work in the investment banking industry like a lifetime ago. It feels like a lifetime ago. It was like 8 years ago. And yeah, moving from project to project, you're moving between technologies, you're moving between modes of programming and like their structures and their rules about how they do things. And it's been able to maintain the flexibility, communicate, listen to people, listen to what they want, play by their rules, and then know when to maybe push back against them when you've maybe got something that you really need to do and say, hey, in order to pull this off, I maybe need to break a rule. Can we maybe reach some sort of accord there? Yeah, it's unfortunate in that quite a couple of the games I've worked on, I know the people in advance. Games industry is a very small inbred environment by and large, particularly in indie development, which is where I tend to be doing a lot of the programming. So it's okay, because most of the time they know who I am. And so they're like, right, we're kind of trusting you here. But if this all goes belly up, like you're getting it. I'm like, oh, okay. So yeah, it's been unique from project to project, but by and large people are willing to trust you if you're going to go in and do something, and they just hope it works out. Communication, that's where it is. Just don't be a dick. Number 1 rule. It's the first time I swore. Well done. I'm really pleased with myself. You have no idea.
I guess just one last question. I was wondering if you are aware of any sort of using AI beyond just, procedural generation for environments, because the real environments will have metabolism, like grasses that grow. Is any company looking into that? So they're building more natural environments?
I guess when you look at, so No Man's Sky did this to a certain extent. Their procedural generation systems, they actually have separate subsystems that dealt with flora and fauna on each planet. And what was interesting about that game is, I mean, it's largely rule-based, mathematical in nature. But what they were doing is that each system informs another system. So like I said, the flora system's actually being influenced by the planet system. So when it generates the original terrain, it knows how far away it is from the nearest star, and maybe it's got some atmospheric properties that then influence the type of flora that it generates. It's something I would really love to research more and find out more about what they did, because they spent years on this tech to actually get it to work. I think that's like a really interesting challenge going forward is, and kind of Minecraft, the GDMC was kind of addressing this, these multi-objective procedural generation problems where we have all these particular quantities that we're trying to address and balance them in a way that makes sense. And I think No Man's Sky was like the first real step towards that. I'd be interested to see more kind of machine learning driven applications towards it. The problem is that that game was vast in scale and it took them several years to build it, and it was a gamble. A lot of people forget that now actually No Man's Sky is doing really well, and it's got a really great community. People are really excited about it. The game did not receive a particularly positive fanfare at launch, and they've worked really, really hard in turning that game into something really special. And I periodically go back to it once a year and go, what have they added? Oh, this is cool, this is new, this is fresh. I can't think of anything else off the top of my head, but it seems like that's like you've got an answer.
I'm not going to pronounce it correctly, but Ultima Ratio Regime.
Oh yeah, Ultima Ratio Regime. Mark Johnson, who is down in University of Sydney, is it now? He's in Australia. Yeah, Ultima Ratio Regime. Mark was originally a PhD student in York who worked on this project. It essentially built entire cultures. The idea was it's a traditional roguelike where you are placed into a world that is, it's all traditional roguelike ASCII art, top down, and it builds the entire, the landmass, the city structures that exist, the cultures that exist within those cities, the topography of the city, the libraries within the city. You can go in and read a book in the library and it's actually got maybe a piece of history about that city and its conflict with a neighbouring region or what have you. And that was like one of these really complex and really rich kind of multi-objective procedural generation problems. And it was utterly fascinating for us because, so we both met Mark, and lovely person. He's not from AI, he comes from a humanities background and was just really interested in building this. And he's like, this is my project that I'm building, and we're like, oh Jesus, I put the rest of this to shame. He subsequent, I think he finished development on the project. I'm not sure if it was ever made commercially available, but he has, or publicly available to download, but he has done numerous talks and kind of papers discussing the complexities of the system, because even something like generating the statues that appear in like a garden, or the vases that appear in that garden, and like the designs that were being used on them, or the faces of the people in each region were actually being pulled from multiple different sources, and that was influencing their final